Hello and welcome to the Section 3 notes. This is Unit 5 and this is a section about triangle similarity using AA. So when we talked about, when we talked about congruent triangles, we had all those different things. Angle, side, side, all that kind of stuff. We have the same properties with triangles and similarity. So what we're going to talk about is angle similarity. So AA stands for angle similarity. Okay. And the other thing that I want to talk about is similarity again, and reiterate what that means. That means that you have two figures are proportional. All right? Means they have the same shape, but they're different sizes. So same shape, different size. All right? And we're also going to reiterate something about similarity, and that means that the corresponding angles are congruent, and that the corresponding sides are proportional. So corresponding sides are proportional. Proportional. And when I talk about proportional, that means that fractions are equal. Fractions / numbers are equal. All right. So let's take a look here, and it says, can we map triangle ABC to triangle DEF using only a dilation? Okay, and the answer to that question is no. Okay, if you take a look at this, what you would need to have these two be they'd have to be oriented in the same way. They would have to look. If you had like a smaller piece here, you would have to have, E, D, and then F would have to be over here. Okay, and the sides would have to be parallel. These two would have to be parallel. These would have to be parallel, and these two would have to be parallel. But when you just strictly look at ABC and FED, you don't have that. Okay, but you would have to use a sequence of transformations. And what that means is that you have more than one transformation. So more than one. But if you look at this, what you notice maybe was that if you took ABC, and it looked like it was mirrored over some line M. Okay, so you have a reflection. Okay, a reflection, and then you have a dilation about point O, okay, and that makes FED just a little bit smaller than C prime, B prime, and A prime. So you have a reflection and then a dilation to get there, okay? So you have to kind of recognize, whether they are, a series of transformations or if it's just a single transformation, okay? So similarity transformation is one that preserves the angle measures, okay? And preserve means that it keeps the same, okay? Preserves means that it doesn't change. Doesn't change, okay? And, things that do that are dilations, rigid transformations like what we did in Unit 2, and a composition of dilations and rigid transformations, okay? So two figures are similar if and only if there is a similarity transformation mapping one figure exactly onto the other, okay? And so, let's just take a look at this. And it says, is triangle LNM, so here's LNM, similar to L double prime, N double prime, N double prime, okay? Now, what we notice here is that the dilation, okay, of LMN, or LNM, sorry, okay, the center of the dilation is actually the origin, okay, it's the origin, okay, and this is done by a scale factor of, I believe, 2, Okay, and the way I can tell is if I take n, connect it to the origin, and then n prime, okay, that has a scale factor of 2. So I have n is equal to 2. And then what we do is we translate that figure down how many units? So from n to n double prime, that's going to go 1, 2, 3, 4, 5, 6, 7. So that means that we're going to translate this down 7 units. Okay, and that's it. That's all we're going to do. Okay, so, not too bad. It's just identifying exactly what you're doing and exactly where they're coming from. Okay, so proving similarity. Okay, so what I want to do here is what information would be necessary to prove here that the two triangles are similar if we are unsure of the similarity transformations. Okay, so what I know is true is that angle P is going to be congruent to angle M. Okay, I also know, so P is congruent to M, I also know that Q is congruent to angle L. So angle Q is congruent to angle L. Okay, now because I know that these two angles are congruent to these two angles, that means that angle O is going to be congruent to angle N. Okay, and so remember that angles are preserved, so that angle measures are preserved. Angle measures are preserved, okay, and by preserved, I mean that they don't change. They don't change. So that means, so angles are preserved in similar figures, okay? And so, and in triangles, okay, you can then use that thing that's called the third angles theorem, which allows us to say that angle O is congruent to angle N. Okay, so that's what I've got. And so what I need to do is then, kind of look at this theorem here that we've got here, and it says that if two angles of one triangle are congruent to two angles of another triangle, then the two triangles are similar. So what I know here is that if I talked about angle P, Q, and then O, and then M, L, and then N, what I can say is that triangle P, Q, O is similar to triangle P, Q, or I'm sorry, M, this is an M, L, N. Okay, and that's how I name that. Okay, remember you have to name these by using their corresponding sides. So P corresponds with M, Q corresponds with L, and then O corresponds with N. And that's how I'm able to name this. Okay, and so and the reason why we just need two triangles or two angles instead of three is because of the third angles theorem, saying that these two angles would be congruent provided you have this pair of angles that are congruent. Okay, all right, that's all I've got for that page. Let's move on. Okay, now we do the fun process of having a proof. Okay, and so what I know, based off of this information, okay, we are only given that segment AC is parallel to segment YX. And I want to prove that this triangle here, ABC, is similar to triangle YBX. Okay, so now here's what I know. All right, because I have two parallel lines here cut by transversals, okay, I can automatically come in here and just do this. All right, I know that angle C is congruent to angle X because they are corresponding angles. Okay, I also know that angle A is congruent to angle Y because they are corresponding angles. Okay, what that gives me is that gives me two pairs. Okay, angle Y is congruent to angle A here, or angle BAC. This angle here is congruent here. So I have two pairs of angles that are congruent, resulting in the fact that angle B is also congruent to itself, which means that these triangles then are similar. Okay, so let's do that. All right, let's come in here and let's draw out our statements and reasons. Let me do statements. And then reasons. Okay, so the statement that I have is that AC, so first statement is that AC is parallel to YX, okay, and that's given, okay. Now I know the holidays are over right now, but we do have various holidays coming up, like Christmas in about 11 months. So get ready, folks, because Santa never left. He never leaves. He's always watching. He's always judging whether you're being a good boy or a good girl. Okay. All right. So now what I know is that these two segments are parallel. Okay. These two lines are parallel. Then I know that that tells me that angle BAC. So let me write this down. Step 2. BCA. Angle BCA is congruent to angle X. Okay, these two angles are congruent because you have two parallel lines cut by a transversal. These two angles are corresponding angles. So part 2 in this is that they are corresponding. Okay, corresponding angles. Okay, and then the third statement that I could say is that angle BAC here, angle BAC, is congruent to angle Y. Okay, and the reason why I know that is because it's the same thing. They're corresponding angles. Corresponding angles. Let me write that here, that these are angles. So then what I can then conclude is that triangle, so in statement 4, is that triangle ABC is similar to triangle YBX. And the reason why I can say that is because of the angle-angle similarity theorem. Similarity. Okay? And that's it. Okay? That's all we're doing. All right? So, it's pretty easy just to show you, looking at the picture, but writing it out takes a little bit of time. Okay? But we're going to have fun anyway. All right. The other thing that I know here, okay, and you could do this a number of ways. There's no one way to do this one. But what I know is that JK is parallel to ML. Okay, and I want to prove that JKN is similar to MLN. Okay, that this triangle is the same shape, just a different size. Okay, and so what I know is that since these two sides are congruent or parallel, okay, I can say that angle J is congruent to then angle M because those are alternate interior angles. Okay, I can also come in here and say that angle K is congruent to angle L because those are alternate interior angles. Now that I have two pairs of angles in two different triangles that are congruent to each other, I know that they are similar due to angle-angle similarity. Okay, so I'm going to come over here and I'm going to write out my statements and my reasons. Okay, first statement that I know is that JK is parallel to ML. Okay, and that's given to us. Now, I don't need to tell you who gave you that gift. You know that it's Santa Claus. Okay, and he's real. He actually came to my house over this past Christmas and gave me gifts of ski gear. I don't know why he knew I wanted ski gear, but he gave me that anyway, all right? So there's that. He exists. He's real. All right. Then the other thing that I know is that in step 2, okay, the second statement is that angle J is congruent to angle M. Okay, and the reason that I know that is because those are alternate interior angles. Okay, alternate interior angles. All right. The third statement that I can make is that angle K is congruent to angle L. So the third statement is that angle K is congruent to angle L. The reason I can say that again is that those are also alternate interior angles. So alternate interior angles. Okay, and then the last statement that I want to make is my proof statement. That I have two pairs of angles that are congruent. And so my fourth statement is that triangle JKN is similar to triangle MLN. Okay, and the reason why I can make that statement is because of the angle-angle similarity. Okay, and that's it. Guys, this is really fun. I'm having a good time. I hope you enjoyed this. I know you may not like proofs that much, but they're fun. And guess what? Santa's watching. And if you don't do your proofs, who knows if he'll come down your chimney. Hope you had a good time. See you later. Bye.